Now we have got an inclined plane. 5.7 kilogram object is lying on the inclined plane and which is attached to a string, and that string is going along a pulley, and we've got 3.2 kilogram suspended by a string. You can ignore friction in this question, but I will ask you to find the same question with a friction at the end of the video. And the question is asking you the direction and the magnitude of the acceleration. So first of all, that I am going to draw here is to put the free body diagram for 5.7 kilogram object and see what kind of forces I will obtain. But I'm not planning to use conventional x and y coordinates. I will use y component, y axis as perpendicular to the plane and x axis as parallel to the plane. Therefore, weight is going to be acting over here. If I have to put that weight over there in the free body diagram, it's going to fall somewhere in between here. Now this is 37 degrees. Does it say 37 degrees? This is a question in your book. This is 35 degrees actually. And now if this is 35 degrees, you have got a right angle over here, and this is going to be 55, and here is a right angle there as well. Therefore this angle is going to be 35 as well. And this angle is the same angle over here as this one, which is 35 degrees. Normal force is acting on the object, and normal force is always perpendicular to the surface. It's acting in that direction, normal force. And I put normal force over here as N. Tension is acting parallel to the plane, and it's over here. Tension is applied to the right. Is there any other force? If there was friction, I would put that friction in case it moves right or left, depending on the motion, the relative motion. I would put friction as well, but we can ignore friction in this case. I will move on to free body diagram for 3.2 kilogram object as well. It's going to be a simple one. Weight is acting downwards. Weight of this object, which is 3.2, I should say. And then tension is applied upwards. So I still don't know if the system is moving in the clockwise direction or anti-clockwise direction. I think in this situation right now, I need to do some calculation to see which force is applying bigger force to the clockwise direction or anti-clockwise direction, and then I will decide in which direction the acceleration will apply. So I need to find the weight first of all, weight of the 5.7 kilogram object, and then I am going to find the components of this weight, because this weight has a diagonally applied to the object, and I need to find the x and y components. Simply, I can find the y component of this weight as weight multiplied by the cosine of this angle, which is cosine 35. It is cosine because it is adjacent to the angle 35. And x component of this weight will be equal to weight multiplied by sine of this angle, because it is opposite to this angle 35. So this is 35. So I can only look at the components of weight over here to identify if it is moving to the right or to the left. Let's find W sine 35, which is equal to 5.7 multiplied by 9.81 multiplied by sine of this 35, and that is going to give you 5.7 32.1 newtons. So this force is applied in that direction. So you can see that there is a force applied in this direction which is 32.1 newtons. So this force is the one which is trying to pull this system in anti-clockwise direction. Let's find out the weight of this object, which is m times g, which you're gonna get by multiplying 3.2 by 9.81, and that is going to give you Now if you look at the forces applied in the clockwise direction, or the forces which are trying to rotate the system in the clockwise direction, you will see that this is 31.4, and the forces applied on the system trying to rotate the system in the anti-clockwise direction is 32.1. Therefore, I can now decide the direction of acceleration which is going to be in the anti-clockwise direction. Therefore, this one is going to slide down, and 3.2 kilogram object is going to go up. So, after knowing that, it will be easy to write the net force acting on the objects. And in this case, net force acting on 3.2 kilogram object will be equal to, since this is going up, this is going up, right? Yeah, this is going up. Tension will be greater than the weight of this object. According to Newton's second law, net force is equal to mass times acceleration. And which mass I'm going to use? Since I'm looking at an object which has a mass of 3.2 kilograms, that is the mass that I will use multiplied by acceleration. Tension is an unknown. I can calculate weight, but I don't know acceleration, so there are two unknowns. And I need one more equation to find this out. If you look at the 5.7 kilogram object, I can write a net force. Now, look at the system is in equilibrium in the y direction, so therefore normal force is equal to W cosine 35, but I don't need to find this one. The system is not in equilibrium in the x direction. The system is accelerating to the left, according to here, therefore W sine 35 is greater than tension, and which applies a net force. The subtraction of W sine 35 minus t is going to give you the net force, which is equal to again mass times acceleration. This time mass is 5.7 kilograms times acceleration. If you do this calculation, you are going to get 32.1 minus tension is equal to 5.7 A. And now I'm going to drive t over here and insert it over there. T will be equal to 32.1 plus 5.7A. Now if I take this one over here, tension is 32.1 plus 5.7A. Is it plus or minus?
Minus.
Minus. This is minus over here. This is minus. Minus mass 3.2 multiplied by 9.81, weight of the object, which has 3.2 kilograms mass, is equal to 3.2A. Now, what do we have? 32.1 minus, let me do this calculation. Let me just write this one and I will do the calculation at the end. 3.2A plus 5.7A, and that will be equal to 8.9A. Therefore, acceleration will be equal to 0.079 I found, but you can round it to one more significant figure, meters per second square. But I shouldn't have done these calculations, so I should have done all the calculations till the end, but this is what you will be getting. So here is, in two significant figures, the acceleration of the system. Now please find if the system is going to move, if there is a friction and the coefficient of static friction between the surface and the block is 0.2. Tell me if the system will move. If it moves, what will be the acceleration? Okay?